All right, so let's start talking about what we're going to actually do with this data that we've been figuring out how to pull into our data frames. So I'm going to go ahead and share my screen again. And so the first thing we should discuss is charts. What is up with that? What's up with charts? Why do we care about charts? Does anyone have any thoughts on charts in general, why we should bother with them, as opposed to, we could just go do some math on these data sets, right? We could just go figure out some medians. We could go figure out some ranges, some modes. We could figure out some, sorry, yes.
I was just going to say the charts helps you actually visualize the data in a clear and organized manner, so it's easier to understand.
Absolutely. That is totally right. And I think that when it comes to charts, it can be helpful to consider, even if we did all of the math and the statistics, we're talking about, we could pull out the names of some old dead mathematicians and do some tests with some random people's stuff, and we could figure out all sorts of crazy mathematical properties of this stuff. But at the end of the day, we still have to convey it in a nice, organized manner, and charts are helpful for that. And besides the conveyance of the information, let's discuss the actual data itself. I've pulled up Quorum Studio again. I've got this same set of data that we just went through, that we tried loading in the height of male and female by country. And looking at this data, does anyone have any thoughts about what this data implies? You can feel free to look at it on your side as well for a minute here and consider what it says. Are there any thoughts about what this data implies?
Possibly geographic locations of tall or short or relatively sized people.
That's a thing that we could probably figure out from the data. Yeah, but that's sort of the broad abstract of what's possible with the data set, right? And I think that's true. I think you could use this to get a sense of generally, geographically speaking, where people are shorter or taller. But that's the broad strokes of what's possible. I'm asking more, what's the answer to that question according to this data set? What is implied by this data set towards that? Anyone have any thoughts? I've given you all at least a solid 60 seconds to look at all 200 of these rows and to carefully analyze the numbers inside. But I will say that I would not call myself the most amazing guru of data science ever, but I have some experience with data science, and I will say, looking at this data set, the values contained within, if I were to try and guess as what this implies, I would say I have no idea. I have absolutely no clue what this means, because it's 200 rows of a bunch of mathematical data, all just sort of spread out. And we could use some mathematical tests to try and derive some stuff, but eyeballing this really doesn't do me anything, because it's just too much information. It's 200 rows of a bunch of different names of countries with a bunch of different values. This is not really eyeballable data, right? To use something that would most certainly not pass in a game of Scrabble, this is not eyeballable. But when we're using mathematical tests are obviously very powerful. We can get a lot of statistical information out of them, but those are also difficult to pass as sort of eyeballable information. If I provide you with a statistical test, the first question that you might ask is, what is this test? Especially if you are a layperson off the street. If I tell you that, oh yes, this data has excellent viscosity, you might look at me like I'm a crazy person, because what the heck does that mean? I don't even know what that means. It's just a statistics term, I think. There's a lot of value to charts because it lets us, as was said, convey our information in a way that's organized. It's also, it lets you get sort of a gut instinct on the data that you have. It's not comprehensive. We can't trust it with everything. We have to be careful with what we're pulling out of just a chart, especially if the chart's not presented well. We could create a misleading or deceiving chart if we do it wrong or if we are malicious, but there is a lot of value to a well-made chart. So that's why we're bothering with all of this, right? In terms of all of this, it's also important to consider that we're doing this in the context of data science. And, you know, for a lot of folks here, we're talking about schools, we're talking educators, we might be talking academic settings in terms of like publications and sort of stuff like that. And that's totally places where this is used. But data science also matters a lot in the broader whole of life. Just sort of spitting it out there. For folks around here, how recently have you seen charts, or tell me about some of the charts that you've seen recently or data visualizations that you've seen recently that have impact on you or that matter to what you are doing in your life?
I get a chart from the energy company about how much energy is being used at my home, and it compares to others around me.
Totally. That's a great example. We get something similar here. Yeah. You can get a sense of what's my power bill look like over the course of a few months. You know, am I using more right now than I did last year? Yeah, that's a great example. Anybody else have anything they'd like to contribute?
Yeah, I typically consume charts from Defender, which is like an Azure-based mobile device manager, just kind of telling me how patched up my systems, my connected systems are. At a glance, really nice. And, you know, they highlight them green, yellow, red for me.
Great.
Making it easy.
Yeah, extra visual content that's being presented to give you some extra insight on the stuff, just sort of at a glance. Yeah, totally. Anybody else have anything?
Well, in my world, I work in higher ed, and I'm the data person for my college. So I have so much data coming at me from different things. It's nuts. So
yeah, you see a chart or two every once in a while.
Yeah, on a daily basis, to say the least.
Totally. I suspect I don't actually need to try and impress on you guys how much charts are actually helpful, but I would like to provide one extra example that is personally something that I have used a lot recently. I'm going to go to Google and I'm going to go to Clark County, Nevada COVID cases. And right here on Google, it provides me with some information about, using this line chart here, how many cases of COVID have been reported in my county where I live as of about a year ago. And aside from the fact that this gives you a sense of what's going on, this is a chart that I personally have changed what I have been doing in my life based off the information that I have been getting. There was a point here a few months ago where it felt like COVID had mostly dipped down to safe and tolerable levels, and I wasn't too worried about it, and I kind of forgot about it for a little while. And then I ended up looking at it again a bit later, and I could see that the information is implying that it's been creeping back up here, and I went from not wearing a mask when I went outside for a while to nowadays, if I'm going into a crowded area, I do wear my mask again. And that's something that, regardless of whether or not you're doing that, I personally changed what I was doing based on not just data, but a visualization that was presented to me based on something really going on in my life. So this is the sort of thing that it presents information, but depending on the kind of information that you are presenting, what it implies for the folks that are looking at it, it might actually mean that you do something differently. It might imply a change in your behavior based on the information that's being presented, right? So this is something that's not just a useful thing to have for our academic setting. It's useful in a broad context, and the ability to not just make, but to understand the message behind these charts is valuable in the broader context of what we're doing. So I have waxed philosophical for a while about how charts are cool, but we should actually do something with them now. For anyone who's following along, I am using the online reference that you can find on the schedule for the overview of chart types and examples. You can find this exact same code that I'm about to run there. And before I get started, is everyone on the page of where to find this code to try it out themselves and to move along? I can sometimes get caught up in my own explanations of stuff. So if I'm ever leaving anyone behind, please let me know. I would absolutely prefer that you interrupt me so that I know where you're at if you need to catch up or if you have a quick question, rather than just moving on with whatever I'm saying. But I'm not hearing anything, so I think that means that we're all here. So before we do anything, I would like to just look at this code. First off, instead of one use statement, we still have this one use statement for libraries.compute.statistics.dataframe. But we have 3 more now that we're adding in. We have libraries.interface.controls.charts.barchart. We also have use statements for libraries.compute.statistics.columns.textcolumn and libraries.compute.statistics.columns.numbercolumn. Now, one of these is pretty obvious. That second use statement for the bar chart. Why would we need a use statement for a bar chart?
Is that what's telling it to create, like to create the bar chart?
So it's not
Accessibly.
creating the bar chart. The bar chart is going to get created down on line 24 of this code. But importantly, we can't create it without first telling the libraries, we need this thing. We're going to end up using this. Please let us have it, right? 3 and 4 are a little bit funny. We have use libraries.compute.statistics.columns.textcolumn, libraries.compute.statistics.columns.numbercolumn. And I'm going to quickly skim the code, but I do not see anywhere where we make a text column or a number column in this code. So why do we have those use statements?
For the accessibility?
That is a good guess. We do not need it for the accessibility, although that's an entirely reasonable thing to assume they're related to. To put this in a different way, because I'm asking trick questions again, do we need these 2 use statements, text column and number column?
No.
No, we do not need these. It's kind of weird why these are here if we don't need them. But I wanted to highlight them because the reason that these are here is because the code that is present in this tutorial is part of a pared down copy of a different tutorial where those do get used. Will this hurt our program to have the use statements for text column and number column, even though we're not using them?
No, might make it load a little slower though.
Yeah, it doesn't really matter. You can have extra use statements and it won't hurt anything. We're not using them. We don't need to have them. If I go and copy paste this in the Quorum Studio, I might get rid of them just because it's not doing anything. But it doesn't hurt our program to have these extra use statements. If you ever think you're going to use something, you put in a use statement, you end up not needing it. If you don't remove it, it won't crash your program or anything. You'll just be asking for, please allow me to use extra stuff, and then you won't end up using it. And the compiler doesn't really mind. It has a lot bigger fish to fry than worrying about the text column or the number column. There's more time consuming things it's got to worry about. You won't even notice that you have the extra use statements. So those are not important. They're not necessary, but I just wanted to highlight when you're using these use statements, you can't ask for something you don't need and break your program. The use statements, you just need to make sure you're asking for enough stuff. It's the ones that are actually important here, or we're asking for, please give me the data frame, please give me the bar chart. The other stuff, it won't hurt anything that we ask for it and that we don't end up using it here. Now, next line of code is a familiar one, data frame frame. What are we doing here?
Calling the frame?
Yep, we are making a data frame. So on that very first line, we said you use libraries.compute.statistics.dataframe. We asked the programming language, please let me use data frames. On this line, we're actually making a data frame. And of this line, it is data frame frame. The first one being data frame, one word, capital D, capital F. Second word, frame, all lowercase. Could I change this line of code and still use data frames? Or more specifically, what part of this could I change and still use data frames somewhere further on in my code?
The lowercase frame. It's just
lowercase
a
frame.
name.
Yeah.
Yep, that's right. It's just a name. So the data frame, that first one, that's really important. It's got to match exactly with what the name is up in the libraries in order to get the right thing. But the second one, that's just a name. I could name it literally anything. That could be Jacob John Jingleheimer Schmidt, and it would be fine. It would be really inconvenient to program with, but it's a totally legal name, right? Now, the next line of code, frame::load, and we're using a different data set this time. This one is data/dogs.csv. And interestingly, I'm just noticing this. This code appears twice on this page. There's once that appears up in this read-only section. This isn't part of the actual compiler. It looks like there's a slight error on this page. There's actually single quotes being used on this part. The compilable section down below, that's actually a runnable IDE, has the proper double quotes though. So if anyone's looking at that and wondering why do we have single quotes, they're supposed to be double quotes. Don't feel like you've messed something up. It's these should be double quotes in this.
Hey, William, let me ask a quick question. So if I were to change the name of data frame to say Bob, then that means everywhere below there where it says frame::, I'd have to change that to Bob: all the way down,
Yep,
right?
that's exactly right.
Okay.
Yep.
All right.
So we're also, because we're using a new data set, I'm going to go grab that data set at some point. I'm not going to do it right this second because I'm going to start by just doing it inside of the website here. But for right now, we're going to be using data/dogs.csv. It's that same sort of load call that we saw previously. And then we have 5 new lines of code. The first one is frame::add selected factors, left paren, quote, breed group, right paren, or sorry, right quote, closing quote, and then the right paren. So frame add selected factors breed group. What does that mean? And this is an unfair question for those who can look at this, because there's actually a comment right next to it that says this will pull out the breed group from table and label on the x-axis. But with that in mind, we have some insight as to what it's going to do, because the comment is telling us what it does. That's the point of a comment. But what does that actually mean? Add selected factors.
You better explain that one. It's not very intuitive.
Well, that's fair enough. So when we say add selected factors, this is going to be part of what we're doing with our chart. The comment on this points at that, right? That it's going to use it as the label, or it's going to use it as a label on the x-axis. But more broadly, when we say that something is a factor, basically what we're saying is that this is going to be something that we are making comparisons across this different grouping, right? So when we're saying add selected factors for breed group, what we're saying is we want to take the breed group that's in this data frame, and we haven't looked at this data, but we'll do that in a second. We're saying that in the data, there is something called breed group, and we want to make all of our comparisons across the breed groups. So if I scroll up here, or actually if I scroll to, I did think it was on this. Well, that's okay. We will go ahead and, oh no, here it is. There's a link to the tutorial where this information was pulled from. And there is inside of this a description of what this data looks like. So the data looks like the top row, the headers, the columns are breed group, max weight, minimum weight or min weight, max weight, and min height. And then in the breed group, it has things like toy, hound, terrier, working. And then the weight values imply how heavy those breed groups tend to be in the different breeds of dog, or the different groups of breeds of dog. So when we are saying add selected factor, what we're saying is in that data frame where we loaded the dog's information, we are saying when we start doing comparisons on this stuff, we want to consider breed group to be a factor, or otherwise something that varies across the different dogs that we are doing all of our measurements across. Does that kind of make sense? And Andy, if you feel that that is a lacking explanation, and if you'd like to provide extra context, feel absolutely free to provide extra stats context as you'd like.
No, I mean, like, it's a complicated concept. I mean, that explanation is one way to view it. I mean, there's probably 100 different ways that it could be described, and it sort of feels like one of those concepts that it takes a little bit of like practice to play with it, and then once you've done it a few times, then you re-explain it, and then you kind of get a feel for it over time. But I also wonder whether a lot of the terms that we're using in our statistics library could be changed to make them more intuitive, but it's not entirely clear what the right words should
Sure.
be. But so,
I mean, is the factors always going to be the x-axis?
By default, yes. Although I think that you can apply some fiddling to the charts once we start getting into the extra options on them that allow you to flip the axes and to do some customization on them.
Because I mean, factor seems to be just categories, but okay, yeah, all right.
Yeah. We'll see when we build this chart the way that, like you're saying, it's basically going to create the categories on the x-axis for us for this particular chart. Past the add selected factors, we then have add selected columns, and we do add selected columns 4 times. The first one is add selected columns maximum height, and then frame : add selected columns minimum height, or sorry, maximum weight, then minimum weight, and then we'll do it again for maximum height and then minimum height. So the selected columns here, we have already specified that the breed group is our selected factor for this, and we're making comparisons across the categories of the breed groups. And what we're actually measuring inside those categories is going to be these selected columns. So for the breed groups, starting with the terrier or the working or the play breed group, whatever, in each of those groups, we're going to independently measure what is the maximum weight, the minimum weight, the maximum height, the minimum height. We're going to put all of that into our measurements within the factors, within the categories. Now, so far, all of this has just been operations on the frame. We haven't actually made any chart yet. All we've done so far was we've just informed the frame that we're going to be looking at it in a particular way, right? And then we come down to this next line where we say bar chart equals frame : bar chart, left paren, right paren. So what is going on in this line of code?
It looks like you're creating a bar chart called chart, and you're saying that you want that to equal your data frame that you made earlier named frame in a bar chart.
Yeah,
form.
That's about the gist of it. This line of code is a little bit strange when you compare it to back up on line 11 in here. We said data frame, there was no equals. That was it. We just said there's a data frame. It's named frame. No other information is required. Just give me a data frame. And it's going to be blank. It's going to be default. Just give me a default data frame. And that was the whole line of code, right? In this case, we have bar chart. So this looks really similar up until this point, right? We're saying, hey, I'm going to need a bar chart variable. The variable will be named chart. But instead of just asking for a default one, I'm using the equal sign, and we're getting that bar chart from somewhere. Something is providing it to us instead of just making a blank default one, right? And so in this case, we're using frame : bar chart, left paren, right paren. And like you were saying, we are getting it from the frame. We are asking the frame to provide it. And this is something where the frame has a specific piece of code that it can call because someone wrote it in a different file. And that's part of what you were asking for when you said, hey, use libraries.compute.statistics.dataframe. You're getting some code that someone else already wrote somewhere else. And in that code that someone wrote somewhere else, it has a little piece that says, hey, if you ask the frame for a bar chart, I will figure out how to make you a bar chart that looks like what you've asked for in the frame. So that's what's going on in this line of code. Is it's only 4 different words with a couple of little bits of punctuation dispersed in there, but a lot is going on in that. Are there any questions about how we're getting this bar chart from the data frame? Or what this means? Okay. Once we have our chart, we can start doing things on the chart just like we've been doing with the frame. So up above, we have a whole bunch of things where we say frame, colon, ba, 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 something. We do stuff with it. Now we have chart colon, and we say show legend, and we have in between the parentheses false. What do we expect that this will do?
It won't show the legend.
Yep, we will have a chart. It could have a legend, but we are saying, please do not give me a legend. Is that a good idea? Should we choose not to have a legend on our chart?
Depends on the data.
Absolutely, depends on the data. I suspect that we'd probably benefit from having a legend on this one, but let's try it out without the legend and we'll see if we like it. And then we'll work from there. But at the end of the day, some things will benefit from it. Some things, it might be extraneous, it might not be necessary. Beyond that, we now have chart colon set title. And then the title we have here is example of displaying dogs.csv. What do we expect that's going to do?
We'll give you a title, like a header on top of
Yep,
the.
a header. So yeah, the title will be displayed at the top of the bar chart and it's going to read example of displaying dogs.csv. All of the stuff that we've done so far, we have a bar chart in our code. Can we actually look at it with everything we've done so far? And as a hint, the next line of code underneath this is chart colon display. If we don't call chart colon display, what will happen when we've done all of this? What will our code output?
Nothing.
Nothing. Yeah, that's right. Chart colon display, this last call that we have, basically says once you've taken the bar chart, you figured it out, you've set some properties like showing the legend on it, setting the title on it, all the stuff. When you're ready to actually show it off, you use chart colon display. And in this case, this code includes 100, 100. What is 100, 100? What are those? Any guesses as to what two integers we might be giving?
Size of the display. And
Yep, that's right.
I don't know if it's pixels or whatever it is, but it's the size.
Yep,
So
that's right. When you're running this on the desktop using Quorum Studio, these two values, 100, 100, will be the number of pixels large the window is going to be. It's going to be its width and its height in pixels. If you run this on the website, it's just going to fill the box that we have on the IDEs here. So in that case, it doesn't matter. So this display 100, 100, you could even remove the 100, 100, and there's a different display function that doesn't take them, and that will work, right? I'm going to click build to make sure that I'm not saying lies and it actually compiles, but yes, it does. So I've done all of this. We've basically just walked through and discussed what the code is so far. I'm going to actually go ahead and run it. And visually, I'm going to start by just describing it. Visually, we now have a bar chart, which reads example of displaying dogs.csv at the top. That's our title that we set. It has two axes. It has the x-axis at the bottom, or x-axis at the bottom, and the y-axis on the left side. The x-axis reads breed group at the bottom, and it has a number of categories that have been split up into, where it says herding, hound, mixed, non-sporting, sporting, terrier, toy, and working. These are the different breed groups that we found inside our data of the CSV file. And inside each of these categories, it's got a little box that it's set up. And inside each of those boxes, there are 4 bars. And there is no legend to tell us what these bars are at the moment, so we can't identify them visually. But the different bars correspond to the selected columns that we said earlier: the maximum weight, the minimum weight, the maximum height, the minimum height. And finally, on the right side, or sorry, on the left side, where we have the y-axis, it reads total, and it has value ticks ranging from 0 to 3,000 at 500 unit increments. That's what it looks like visually. Now, I'm going to pop open NVDA, my screen reader. I don't remember if I turned on sound when I started sharing my screen. I'm going to very quickly reshare my screen, because if I don't think you're going to get any audio from my screen reader. right, I'm gonna pop open NVDA.
Welcome to NVDA overview of chart types and examples document.
Can everyone hear my screen reader talking?
Yes.
Cool. So I'm gonna go ahead and I'm currently in the text editing area of the IDE.
Frame add selected columns, minimum height.
I'm gonna press tab,
Enter game button.
enter game button. So when you tab from the IDE, it brings you to a button that if you press enter, you will jump into the game area. That's also where charts are displayed. It's called the game area just for historical reasons, because up until this release where we're doing data science with it, usually this has just been where you would run the output of game projects in your stuff, but now it runs charts as well. So we press enter.
Game dialog. Example of displaying dogs.csv, bar chart with 8 groups and 32 total bars. Use the arrow keys to navigate chart information and tab to access the chart content.
So because of how we have set up our charts in Quorum, this is displaying something in a, it's not just a static image, this is a dynamically rendering active application. This is something you can interact with. And importantly, if you have your screen reader open, it will give you some accessibility cues for how to navigate the data and to get some information from it. So I'm going to start by using the arrow keys here.
X-axis shows breed group and has values herding, hound, mixed, non-sporting, sporting, terrier, toy, and working.
So a lot of this information will sound familiar because it's the same thing that I audio described. And that's the goal of the accessibility system, is that it will provide you with enough information that you can navigate, and it will not just give you alt text level, high level sort of impressions of the stuff, but you'll be able to actually navigate and get to the individual elements. So right now I just went from the top level to the x-axis. If I go ahead and use the right arrow,
Y-axis shows total and ranges from 0 to 3000.
that gives me some information about what the scale of the y-axis is. And now I'm going to go ahead and I'm going to press tab.
Chart area with 32 bars to navigate the chart. Press enter to move into the list of groups or shift tab to return to chart information.
By tabbing from the sort of external of the chart where I am looking at all the axis information, you can get into the main region where the actual content of the chart, where all the bars live. I'm going to go ahead and press enter.
Herding group, 1 of 8 groups, has 4 bars. To navigate the list of groups, use the arrow keys to move between groups in list order. Use enter to move into the list of bars for that group. Use shift plus enter to return to the chart area.
And for those of you who are screen reader gurus and who are undoubtedly agonized by how slowly my screen reader moves, I apologize. For this though, I am now looking at the herding group in the chart. So currently, if I move left and right, I can just sort of navigate between the groups.
Hound group, 2 of 8 groups, has 4 bars. Mixed group, 3 of 8 groups, has 4 bars. Non-sporting group, 4 of 8 groups, has 4 bars.
When I want to actually enter into a group, I can get individual data points from inside that group. So I'm going to go ahead and press enter.
Non-sporting maximum weight bar, 354, 1 of 4 bars inside non-sporting group. To navigate the list of bars, use...
I'm going to go ahead and kill that early while it's talking, giving me instructions about how to move around. But importantly, that was the maximum weight bar, and it informs me what the value of that bar is. And if I move around, I can get information about the other bars as well.
Non-sporting minimum weight bar, 226, 2 of 4 bars inside non...
Just killing that one early again. But each of these will give me some insight, and I can use left and right or up and down to just move laterally through the information. So literally just going from the first bar to the second bar to the third bar to the fourth bar. I can also use
non-sporting maximum height bar,
page down or page up to move through the data in a way that is sorted by the value. So instead of going from bar 1 to bar 2 to bar 3, it gives you the ability within the groups to jump from the smallest bar to the next step up to the next step to the biggest bar. So you can move through not just left to right, but also sort of vertically from biggest to smallest or vice versa. As we get into the other chart types, as this is the overview of charts tutorial, we are going to get some insights into how this works on each of them, but the general gist of it is going to be the same. Each of these charts allows you to accessibly navigate through the individual components to try and get at the meat of the content and not just using a high-level alt text sort of view of the information. Any questions about the the broad strokes of accessible navigation on the charts or anything that's going on here before we continue.
So this might just be off topic, but is this in pounds? Is this in ounces? Because there's not a dog that weighs that.
That is a great question. And the answer to that is that this chart currently doesn't tell us, which is a sign that our chart is probably not set up in a way that's very informative. I would actually argue that this is kind of a bad chart right now. Right now, we have a sense of the breed groups. It tells us what's herding, which values correspond to the herding dogs, the hound dogs, etc. But otherwise, all we have on the left side is total. Each of these values goes from 0 to 3,000 something, and we don't have a legend on this. So visually, I can't even tell which bars go to which things. So I think that this is a good time to take a step back and evaluate what would we need to do to actually make this chart more useful. So any thoughts? I think that Leslie already made a really good observation. It's not currently telling us what the measurements are in. We don't have a sense of what they are. And I'm going to kill the screen reader for a moment so that I can navigate without it talking over me. I think that in the original, I don't think that we actually know from our data set. The data set does not indicate what the values are in. But that feels...
It's got to be pounds for the weight, but I mean, it's the numbers in the chart are strange. I mean, they're in the thousands.
So with the bar chart, because you're using a factor, it's grouping the values for everything that's working into one bar for maximum weight. Bar chart might not be the best way to represent this data.
That's good to know.
If you had one row for each one, then it would probably be more accurate. But right now it's adding all the values that match your factors in your column into one thing.
That's bad.
Okay, that's good to know. So this is, sorry.
Sorry, one more thing. The individual bars within the groups also were not labeled. It didn't sound like.
That's right. So currently, with the bar chart that we're using here, we do not have any legend currently displaying, which means that we are not currently visually informing the user of which of these bars represents which category. The accessibility system doesn't rely on the legend to show it. So listening, it does imply which is which funny enough means that this chart is actually more accessible using the screen reader than visually right now, which is definitely not true for most charts. That being said, I think before we move into the other chart types, let's take a moment and let's make some adjustments to this one. And before I make any adjustments, I actually want to go ahead. I want to move this into Quorum Studio just to go through the steps of putting this all together and to building this up in our own environment. So I'm going to start by, I have my data frame project from before. I'm going to just remove the 6 lines of code that I have here, or 4 lines with a couple of line breaks in them. And I'm going to go ahead. I would like to start building this back up again from scratch. And I'd like you all to help me with that. So I'm going to make a bar chart based on this data. What's the first thing that I need to do?
Call some libraries.
Yeah.
Yep, I'm going to need some libraries. So we're going to need libraries.compute.statistics.dataframe. And I know where it's located because I've been seeing it a bunch in the code that we've been using, and I can copy it from there. If you don't know where something lives, you can always look at the website to try and find the libraries on there. Or if you're in Quorum Studio, we have code completion, which with the current version of Quorum Studio hilariously puts it a little bit further down than it ought to. But when you type in use libraries dot, the moment you hit the period, it will pop open a code completion window, which will give you the different library categories that are available from wherever you're at right now. So right now I'm at libraries dot, and the next options are I could do compute or containers or game or interface or language or network, a few other options. You can use this to help you navigate and find the different elements that you want. So the next thing I'm going to need is a bar chart. I happen to know where this lives, but does anyone have a guess as to where this is located? Or would like to just use the previous code to guide me on this?
Interface.
Interface
Interface.
controls.
Yep. So I'm gonna, using code completion, I am down arrowing to interface, and then I pressed enter. It immediately puts in the next period, which means that code completion pops up again, and I heard controls. So I'm gonna go down in code completion to controls. And if I was using NVDA right now, it would be reading these as I'm moving through. Interface.controls, and I see charts right at the top here. That seems like a pretty good candidate to have bar charts in it. And then because it's alphabetical order, bar chart happens to be right at the top here. So I'm gonna go ahead and put in that. And I now have two use statements, one for the data frame and one for libraries.interface.controls.charts.bar chart. All right, I have my use statements. What's the next thing that I need?
Need to name the data frame.
Yep, I need to make a data frame. It's got to have a name on it. What should I name this? I can name it anything I want.
Bob.
Bob the data frame.
Bob the data frame.
I like it. All right, so I have my data frame now. What do I need to do next? I have a data frame. What needs to go in it?
You gotta load the
Load.
load the
I gotta
CSV.
load it. Do I have the data yet?
Nope. Well, we
No.
no, probably not.
It's on the website, but I don't have it in my project right now. So the next thing I'm going to do is I am going to go to the website. I'm going to go find where we're pulling this from. So this is data/dogs.csv, and I will paste the URL into Slack again once I have it. I'm going to go to a new tab in my web browser, and I'm going to quorumlanguage.com/data/dogs.csv. I'm going to copy that. I press enter, it downloads that, and I'm going to post this right now into the EPIQ channel in Slack. So this is not the first time we've done it, but it's still unintuitive as to what's going on. Any questions about how I'm getting the dogs data set here? Okay. I'm going to go ahead and I'm going to go to my downloads folder where I have dogs.csv. And because I've kept my file explorer windows open from previously, it's fast for me to get back here, but I expect that if you don't have it open, it will take a minute. But from my downloads, I am moving dogs.csv into my data frame project in my Quorum Studio folder. I'm going to give everyone a minute to go ahead and do that on your end, because I know it does take time if you don't already have it open. And while we're taking a minute, does anyone have any questions as to where to find it, how to do that? Are we all on the same page?
This is just for screen reader users. I noticed that if I go to the website, it says page not found, but then if I go into my downloads, the file is there.
Yeah, when you do it this way, and visually too, if you do this visually, quorumlanguage.com/data/dogs.csv, download something, but it's a blank page. It just says new tab. There's no information here at all. This is not like a forward facing page on the website. We're doing a little black magic to sort of pull a public file off of our website here. But all right. Does everybody have the file in the right place now? I shall take silence as an enthusiastic yes. So now that we have that in the right place, now I can actually do something with it in my code. What does the code for that look like?
Bob, load,
Oh,
Yep.
open paren.
Yeah, and at this point I want to pause. In code completion, I actually see that I have a few different options. I have load and it takes a file, or it takes a file and a data frame loader, or load and it takes a text value for the location, or load from comma separated value. It's not important that you know all of these, but the gist of it is that there are sometimes actions that you can use in our stuff that will allow you to use a few different ways to interact with it. And it might be convenient for certain kinds of cases to use something like the file object, where you can give it extra information as to how to navigate to something and use that instead. Or if you're doing something really complicated, I think probably more complex than we're intending to do as part of EPIQ this year, you can do specialized loading with a data frame loader. Or if you just had the raw text, you could load it into a data frame using the load from comma separated value. For right now, though, like I said, it's just load, left paren, a quote, and then I got to put in my file. In my case, I did not put it in a subfolder. It's literally just in the same folder that the root of the project is in. So I've got build, project, run, and source code folders, and then beneath that, I've got my different CSV files. One that's the previous one, and this new one that's dogs.csv. So in my case, I don't want to put any folder name or anything. I just want to put dogs.csv. Entertainingly enough, when you put the dot in the text, it will open code completion because code completion is not picky about where you open it. It just looks for the period. So don't freak out if you start doing that and code completion starts coming up and you're like, what is it doing? Don't worry about it. You can press escape to make it go away if you don't want it there, or you can just finish typing and it'll go away on its own. Now I've loaded the dogs. And now I actually want to put them into, or I want to get the data frame ready to display in a chart. So what do I need to do from here?
Now we got to start doing all that factors column stuff.
So we're going to load, or sorry, not load. Sorry, we're going to select. I'm going to look at the code because I clearly cannot be trusted to remember it from memory.
It's factors.
Add selected factors. That's what it needs to be. So add selected factors.
So you do Bob : add selected factors.
Bob
Okay.
add selected factors. And so this is another case where we have a few different options. We have add selected factor and I could give it an integer, or I have add selected factors and I can give it text. If I give it an integer, what does that mean? If I said add selected factor 0, what is that?
You're probably referencing like an ID column or maybe like a key column in your data.
Something along those lines, yeah. So if we look at the data here, we can see that this CSV is organized. So the first row has our header names, and it includes breed group, max weight, max height, min height, in that order. And what we're doing, sorry.
Oh, I'm sorry. So that was add selected factors headings.
Yes, so that's the
Okay.
one that we use in our example we ran off the website, was add selected factors, and we took the one that took text, that was the headings one. If we had used the other option, the one that has an integer, it's literally just counting them in order. So if I say 0, because we start counting from 0 in computers, it gets the first column and says you're the selected factor. If we count 1, it goes 0, 1, so it moves to the second column and says max weight. I'm going to select that one instead. I think it's more convenient to use the other option to give it the text. So I'm going to use the same thing that we had in the online example. And I'm going to say the selected factors is breed groups. I believe that's how it's spelled. Oh, no, it's not plural. It's just breed group. So add selected factors, breed group.
So when you use the integer, it ignores the first column down here. Like this data down here is not the same data. I get that, but like it says 192, 193, 194. That's just the line of the. It doesn't count that as
actually
0.
That is actually the first row of that particular data set.
So it would be 0 then. Okay.
Yes,
okay.
so that
of that data. Okay.
Yep, of that particular data. That was the other data that we used previously. But yeah,
So
for that data,
we'd have to use 1 for integer then in this case to go to the second. Okay.
Yep.
Gotcha.
Yep,
All right.
that's right.
Hey, William, the CSV
Yes.
that we downloaded has more columns than just what's displayed on that reference tutorial.
Okay, thank you
Oh,
for.
yeah. A lot more data.
Yeah, let's go ahead and let's actually open that up. I'm gonna look at that in Excel real quick, and boy howdy, yeah, that's a lot more than I realized. So, and it's a good thing I didn't just use the one that was up on the site as a exact mirror, because it's clearly it's only showing a small showcase of what's inside it, right? If we look at the actual data, we have more information, including an ID column, which just individually identifies each of them with a number starting from 1 and going down to 105. We have the name of the individual breeds, which means that we could do extra information or extra work on this using stuff other than the breed groups. We could do something like measure it across the individual names of the breeds, right? Also has some other information like bred for. So we see something here that, according to this, the Affenpinscher is a toy breed, is of the toy breed group, and was bred for small rodent hunting. It is kind of interesting to consider. Is it useful to consider the bred for category as part of our chart? Considering as we look down, it seems like every single one of these bred for sections has its own unique value. It doesn't look like there's broadly repetition in this column. So is this useful for our chart? Would we like to incorporate this into our chart somehow?
No.
Probably not.
No.
Yeah, there's not, this is not the sort of data that a chart is particularly useful for, because this is more unique descriptive data, whereas the chart is more helpful for aggregating information that is shared or at least similar enough across things that they can be compared against, right? For another example of that, we also have in this data set, it says image and includes information on the stuff that realistically we're not going to do any comparison in the chart based on these URLs of where you can find images of them. But we've added our selected factors. I shouldn't go too more in depth into the bar charts because I need to remember that Amanda is going to be talking the actual nitty gritty of the bar charts after this. So let's go ahead and just add our selected columns. So on our selected columns, we have a few different things that we're incorporating just to get the previous chart. And that's the maximum weight, the minimum weight, the maximum height, and the minimum height. So I'm gonna go ahead and put those in on my end one at a time here. So I have Bob : add selected columns, maximum height. Bob : add selected columns, minimum height.
Wait.
And if I'm going too fast, please let me know, because I know I am going fast on this one. Adding the selected columns for the maximum weight. And we're adding the selected columns on the minimum weight. So my preparations on the Bob data frame now are Bob add selected factors for breed group, Bob add selected columns on maximum height, and then add selected columns as well on the minimum height, the maximum weight, and the minimum weight. Now, in our original code off the website, we just have 4 steps left. We're going to get our bar chart, which we give it a name. What do we want to name our bar chart?
Dog breeds.
Dog breeds. That's good. We can name our charts anything we want, but generally speaking, although it's a lot of fun to name our data frame Bob, I feel bad for whoever has to come maintain our code later when they see Bob the data frame, if they even realize it's a data frame. All they know is that Bob is adding selected factors or columns, and that's a little confusing. The more descriptive our name is, the easier it is to tell what is going on in our code. But for right now, dog breeds is equal to Bob : bar chart. Bob the bar chart. Well, actually not Bob the bar chart, but the bar chart, which was produced by Bob, is now in dog breeds. We have a couple of things left that we did in our other one. If I don't set the legend on this, what do we expect is going to happen? If I don't say set legend to be true or false.
Take the default value. I don't know what that is, but
yeah, whatever
true?
it is. We'll find out in a minute here, because I think I'm going to skip setting it. But the important thing is, if there are some optional properties and you don't set them, it's not going to break anything. It'll choose defaults, which we have attempted to make reasonable as much as we can. You don't need to necessarily worry about setting each individual thing. Once we have our bar chart, we need to set a title on it. Actually, I'm going to skip that too. I'm going to see what the default on that one is. I'm just going to display it. So I have bar chart dog breeds, and then dog breeds colon display. Now there are 4 options here. Display with no parameters, so it's just the left paren, right paren, and we're done. Display with a Boolean for exit. What does that seem like it would do? If this one's not intuitive, I don't blame you because it's absolutely not intuitive. If you say display and you pass it a Boolean that says true, it will pop open the chart and then it will immediately close. Why on earth would you want that?
Kind of pop up.
It's going to pop up for a split second. The important thing is that the charts need to render in order to draw everything. And then you can close the window. And even after the window is closed, you can still save it to an SVG file, which is the other way you can use our charts. So this is a little helper that if you really just want an SVG generated from a chart, you still have to call display at some point just so it makes the chart and puts it all together. But if you don't want the window, just call display and then use the Boolean. It'll come up, it'll make something, and it'll go away. Do we want that right now?
No.
No.
No, we do not want that because then we won't be able to look at it. We're not trying to put it out to an SVG right now. So if we just want to display it, we're going to give it a value. And as we've described before, this display that takes an integer for the width and then another integer for the height is what we want to use if we're doing it on the desktop. So I'm going to set this to be display at 1,000 pixels by 1,000 pixels. I'm going to build it, make sure it compiles, which it does, and then I'm going to run it. And this is what it looks like if I run it here on the desktop using Quorum Studio, using mostly the same information that I had before. The only difference being that I did not disable the legend this time, and I did not set a title. The title is very helpfully chart title. That is not the best default for this information. So you probably do want to set a chart title on your stuff. It won't crash anything, but the engine doesn't know what to name your thing if you don't tell it, so it just calls it chart title. We do have a legend by default, and we can see that the different colors of bars do correspond to the different values between the maximum height, maximum and minimum of height and weight. But otherwise, with those exceptions, this looks basically the same as we would expect from what we were doing on the website.
So is there a way to take the title off completely? I mean, it's by default it put chart title, which is hilarious. But
yes,
is there a way to put in faults and say we don't want a title?
I believe there is. Although Hannah, you can correct me if I'm wrong on that one.
I think there is. I think it's show title and you pass it false. You'd have to try it to be sure. But
Gotcha. I am not going to do that right now just because I think I've already stolen enough of what is possibly going to be Amanda's session as is going in depth on this one. But now that we have a sense of what's going on with this bar chart, I want to take at least a couple minutes and I want to talk about the other chart types. Any questions further before I close this and move on to the other chart types?
It works if you put that chart type faults in there.
Great.
So if you don't put in the, I didn't put in the 1,000, I just put in just in parentheses, it gives you full screen. That's what the output is. It's just
Yeah,
big.
it uses some default values, and the default values are probably going to be pretty large. Yeah, I think it is intended to be, but yeah. All right. So let's take a moment and let's talk about the other chart types that we have available in our stuff. There are 7 types of charts that we can use inside of Quorum at present, which are the bar chart, which is what we just used. We also have pie charts, which basically you get yourself a circle, you slice the circle into chunks and basically say this percentage of the circle represents this or that. You have the line charts, the same sort of thing that I showed towards those COVID cases that I was showing as an example earlier, literally just lines moving from left to right indicating the rise and fall. We have histograms. Histograms visually look quite similar to bar charts. Is there anyone that can describe what the actual difference is between bar charts and histogram, even though they resemble each other aesthetically?
What the similarities visually?
What they do resemble each other visually, but they are different things. What is the difference between the two?
The bars are touching each other, and the bar charts are not necessarily touching each other. But
The difference is a little bit subtle, and especially because it could be easy to look at them and consider them to be either subgroups of each other or relatives of each other. When we say histogram, what we're really talking about is a difference in what you are measuring. With a bar chart, Hannah previously described how we were looking at, in our bar chart, the values in here. We have, for example, in the working group, the maximum weight is humongous. It goes way up past 2,500. There is not a dog out there that is more than 2,500 pounds, right? But importantly, what this bar chart is attempting to measure is not a question of how many dogs measure a certain much. It is what is the value of this. So it is trying to get a sense of are there, or what is the value of the weight of working dogs? It is some number. That number is probably like 2,600-ish according to this chart. A histogram is not trying to get a value of an abstract concept like weight. A histogram is essentially an exercise in measuring how many things fall into certain buckets of stuff. A histogram would be more apt to be used if we were doing something along the lines of, we would like to measure how many dogs weigh between 0 to 10 pounds, between 10 to 20 pounds, between 10 to 30 pounds, between 30 to 40 pounds. And each of the visual bars on the histogram represents how many things are in this category. It is basically divvying stuff up and counting them within certain ranges of stuff. That's the normal use of a histogram. So they look similar to bar charts, but they are used in different ways. And I do believe that we are going to be discussing histograms tomorrow. Yes, so if you don't know exactly all possible things about a histogram after that vague description, don't worry, that's because we're going to talk about them in detail later. Past that, there are 3 more types of charts, the next one being the scatter plot. What is a scatter plot? Scatter plot, if I can, I'm going to go ahead and I'm going to visually show off a scatter plot here from one of the tutorials. Visually, a scatter plot resembles the bar chart only in the sense that there are axes, which is going to be true of basically any of these that we use. What the heck is going on this page?
I think this example is super complex, so it takes a while.
Oh, it's, yeah. Oh, yeah, it's, well, it's not important that I look at this particular one. Basically, the gist of a scatter plot is that you will have your axes similar to the bar chart, or almost any kind of chart short of the pie chart will have your axes on the bottom and on the side. The scatter plot, rather than representing data as bars or as lines, gets a bunch of individual data points, and for every single data point, it just puts a dot on them. So you get just a scatter of data across your chart. What are some cases where that might be useful? It's a lot more, if every single data point has its own dot, it seems like it would be a little bit more chaotic than something like a bar chart, which is aggregating it for us. So what's the point of using a scatter plot?
If you're tracking something and you need a lot of multiple points.
That's a possibility, yeah. The scatter plot, the value of the scatter plot is being able to get a sense of sort of a shotgun blast of data across an area to see not the aggregation of it into something like the bar chart might tell you an exact value of if I add up all the weights, or I might have like an average or something. I have one discrete value. The scatter plot is more of, look at what happens if we just look at everything all at once and we try and visualize roughly how grouped up everything is or how far apart everything is. It gives, among other things, because charts are not, one exact way to use them correctly for everything, but generally speaking, a scatter plot is useful for sorts of information where you're trying to give a sense of the grouping or dispersion of information, which might potentially involve giving a sense of where things are clustered even across different groups. So you can imagine if we had our dogs example, we start with our working dogs and we've got our toy dogs. If we just sort of throw up a scatter plot, here's each of the points of each breed in this group that and what their weights are. The working dogs are going to be sort of tightly clustered-ish probably. The toy dogs will probably be sort of tightly clustered-ish, but those clusters are going to be way far apart from each other on the scatter plot. It's a different way of conveying that same information that generally working dogs are going to be heavier than the toy dogs, but you also get a sense of how much variation is there within that group, right? That's not the only way to show that sort of information. In fact, the next type of chart that we're looking at, the box plot, as well as the one after that, the violin plots, they also sort of touch on some of these concepts of getting a sense of not just where is something like the average, but also how is it distributed across that. So the box plots and the violin plots using the, in the case of the box plots, sort of having a rectangular region, which is accessible using the screen reader with our stuff. The rectangular region showing how much of the data is distributed away from the average, how far away from the average, and the whiskers sort of extending out to show the furthest points without getting into the technical details of the statistics and the quartile ranges. The violin plot has this sort of weird graphics to it that looks vaguely like violin, thus its name, but basically it's just a line in the middle that's showing the chunk of it, but then the dispersion across it represented by the wide bands that sort of curve outward from it to give it the vaguely violin shape. I'm going very vague on these because it's just about 11 o'clock and we're going to be touching each of these in more detail as we go in through the week. But what we've touched so far, talking about the bar charts, this particular example and how to do it, we're going to see that a lot of the stuff that we're doing in this can be mirrored across the different charts in terms of how you interact with it in code. But the nuance is going to come from what chart is going to better represent and organize your data, and how do we fiddle with the chart to make it better. So something like the bar chart, as was described for this dogs.csv data set, maybe the bar chart can show us something, but maybe this isn't the best way to represent the data. In fact, this is maybe a misleading way to represent it. And what other information can we provide to make it more meaningful? So that's what we're going to be covering in the next couple days here. So any questions regarding the broad overview of charts, regarding the stuff we did with the bar chart, general stuff? Anybody have anything they'd like to chime in with? All right, it's just about 11 o'clock. I think that Amanda will be just a few minutes before she arrives, but I think that this is also a good opportunity for us to go ahead and take a 5-minute break in between the sessions. So if anyone has anything they'd like to chime in or ask about, feel free, but otherwise, let's meet back in 5 minutes.
And don't forget to stop the recording if you don't mind.